Hello, welcome back to my YouTube channel. Today I want to do organic part 2. Now, before we do that, those who have not yet subscribed, please subscribe, like and share the video, because you'll be going to be receiving good and wonderful videos in mathematics, sciences, and the other stuff like motivation. Now, when you're looking at the organic part 2, in the previous video or part 1, I explained about the homologous series, the properties of homologous series and the examples of homologous series. Now, today in organic part 2, I want us to look at what are called the hydrocarbons. Now, before we go into details of hydrocarbons, you have to know the bonding of carbon, so that when I'm explaining about the structures, you are aware. So you have to know the bonding of carbon. The bonding of carbon. Carbon has a valence number of 4. There's a valence number of 4. Now, the 4 valence number simply means that carbon has the ability to form 4 bonds. Carbon has the ability to form 4 bonds. So you need to know how carbon forms 4 bonds. For example, we may have that. We have 4 bonds surrounding the carbon atom. We may have carbon, double bonds there. That is 4. 1, 2, 3, 4. We may have carbon. This side is a double bond. You see that? We may have carbon with a triple bond. For other organic compounds, or those which have multiple bond, the alkanes, we may have carbon with a triple bond and 1 bond that side. So those are types of bonds which are formed by the element carbon. It has the ability to form 4 bonds because it has a valence number of 4. Okay. Okay, now in this part we look at the homologous series. Specifically, we start with these which are called the hydrocarbons. Now, what are hydrocarbons? The hydrocarbons, these are organic compounds which have only the element hydrogen and the carbon. So hydrocarbons are organic compounds which have the element hydrogen and the carbon only. Those are what are called the hydrocarbons. The organic compound which contains the element hydrogen and the element carbon only. And do not forget the word only, because all organic compounds, they have they have carbon, they have hydrogen. So if you don't put only, it defines something else. So hydrocarbons, these are organic compounds which have the elements carbon and hydrogen only. Those are what are called the hydrocarbons. Now, on hydrocarbons, they are classified in usually 2 parts, though we may have 3. So they are classified in 2 parts. 1, we have what are called the saturated hydrocarbons. Then B, we have what is called the unsaturated hydrocarbon. Now, what are saturated hydrocarbons? What are unsaturated hydrocarbons? So at this level, we're going to end here, but we also have what is called aromatic, but we're going to just do this part. Saturated hydrocarbons, these hydrocarbons which have single bond between carbon-carbon covalent bond. So saturated hydrocarbons, these are hydrocarbons which have single bonds. They are hydrocarbons which have single bonds. So these have single bonds. That's a single covalent bond. Single covalent bond. So the unsaturated hydrocarbons, these are organic compounds which have single covalent bond, Example of these are alkanes. Examples of these are alkanes. Alkanes have single covalent bond between their carbon atoms. So all organic compounds which you are going to see with the single bond between carbon to carbon atom they are called the saturated hydrocarbons. This is because this carbon we are talking about is filled up with all the different types of atoms surrounding the element carbon. Okay, so we have, for example, this atom there and another atom there. They have single bond. So covalent compound, these are compound. We know the bond which is formed between non-metals. So when we say saturated, as I said earlier on, these are organic compounds which are made up of single covalent bond. The covalent bond is a bond between non-metals. Okay. Examples of saturated, I said, is alkane. Hope it's clear. Now, B, we go to unsaturated hydrocarbon. Unsaturated hydrocarbons, these are hydrocarbons which contains at least one double or triple covalent bond. One double or triple covalent. Okay, we're going to focus on the double bond. So unsaturated hydrocarbons, these are hydrocarbons which contains at least one double or triple, perhaps, between carbon to carbon atom, where they have a double bond between carbon to carbon, or it could be triple. So those are called the unsaturated hydrocarbon. An example of unsaturated hydrocarbon, we have what are called the alkenes. What are called alkenes. Then we also have the alkynes. We're going to focus on the alkynes. We're going to focus on the alkenes. So these two are examples of unsaturated hydrocarbon. Okay. Now we're going to specify our lesson on saturated hydrocarbon. For this video, we'll look at alkenes. So alkenes, as we discussed earlier on, these are made up of single bond between carbon to carbon atom. Now, when talking about alkane, you have to know the general molecular formula of an alkane. So, from the word alkane itself, all alkanes, they have the suffix of A-N-E at the end, alkane. Then the prefix depends with the number of carbon. The prefix depends with the number of carbon. So, but they all end with the A-N-E. Now, if you look at this, we want to know the formulas of an alkane with the two carbons. So we use the general molecular formula of CnH2n plus 2. This is the formula for finding the molecular formula of alkanes. It's called the general molecular formula. Now, how do we use this molecular formula? For example, you want to know the molecular formula of an alkane with one carbon. N represents the number of carbon. So we want to know the molecular formula for an alkane with one carbon. It will be C1H2 times 1, then plus 2, which becomes, we don't show the 1, CH2 plus 2, then CH4. So an alkane with one carbon has the molecular formula 1, and this is called the methane. Meth means one carbon, 1. Meth means 1. So this is an alkane with one carbon. If you want to know an alkane with, for example, 5 carbon, you want to know the molecular formula for an alkane with 5 carbon, we're going to use the same formula. It's a CnH2n plus 2. So since we want to know the molecular formula for an alkane with 5 carbons, while there is N, we'll put 5. So C5 H2 times 5 plus 2. Then this becomes C5 H10 plus 2. It becomes C5 H12. So an alkane with 5 carbon, it looks like. So that's how we use the general molecular formula to find the molecular formula of alkanes. Okay, so let me list 3 or 4 alkanes. So as I said earlier on, the first alkane, here I'm going to put name. Then here we're going to write the molecular formula. Here the structural formula. Here the structural formula. Okay. Now the structural formula. So the name of an alkane with 1 carbon, we said, is called methane. Meth means 1. Remember, they all end with the same suffix. Okay. Then the molecular formula, as we calculated, it was CH4. The structure formula, you need to spread these atoms of hydrogen around the carbon atom. So this becomes C, then H there, H there, H there. Now, don't forget, I already explained that carbon forms 4 bonds. You have to make sure that the carbon has 4 bonds. Okay? Then the hydrogen will not lie. Hydrogen has a valence number of 1, which means it has the ability to form 4 bonds. So these hydrogen are surrounding the carbon atom to make it stable, and also themselves to be stable. Okay. Then the alkane with 2 carbon is called the ethane. It's called ethane, which is, if you are not sure of the molecular formula, use the general molecular formula for you to know an alkane with 2 carbons. So we have C2H6. Now in the previous video, we said the homologous series, they differ one to the next with the CH2. The difference between these two is only CH2. So 2 carbons minus 1 are going to remain with 1 carbon. 6 carbon minus 4 are going to remain with hydrogen are going to remain with 2 hydrogen. So the difference between the one to the next is CH2. The structure formula for this one is C. Remember, we have 2 of these. Okay. Make sure that it has 4 bonds, the carbon atom. Then you also have this one here. Okay. All together we have 6 hydrogen. 1, 2, 3, 4, 5, 6. Each carbon atom has 4 bonds. Each carbon atom has 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. Okay, it's very important to know that. Okay, an alkane with 3 carbon is called propane. An alkane with 3 carbon is called propane. It's called propane, which is C3H. Remember, from 6, we just add 2 to 6, then it becomes 8. So C3H. The structure formula, we draw 3 carbon. You write 3 carbon. They both have single bond between them. This carbon has remained with 3 bonds to be stable. So it needs 3 more bonds for it to be stable. So the bonds, you have to indicate them clearly. This carbon has 2 bonds already, 1, 2. So it only needs 2 more bonds to be stable. Okay. Then this one needs 3 bonds to be stable. Like that. Okay, so that's the propane. We can continue drawing. We have butane. I want to draw this one. I'll just list them down. Butane, pentene. This is 4 carbon. Pentene is 5 carbon. Pentane. Then we have hexane. We have heptane. We have octane. We have nonane. last one we have, it's not the last one, but we're going to usually end the step, decane. Okay, so you can draw this, you write the molecular formula using that general formula in the beginning, and you draw the structural formula as well. Okay, so those are alkanes. Now, after we know their structural formula, molecular formula, there is also what is called isomers of alkene. Isomers of alkene, isomerism. What are isomers? What is isomerism? Okay, so isomers of alkanes. Isomerism is the process of making isomers. Now, isomers, these are organic compounds with the same molecular formula but different structural formula. Isomers are organic compounds with the same molecular formula but different structural formula. So we'll be looking at examples of isomer. Now under alkane, the first alkane do not have the isomer, the second alkane does not have an isomer, even the third, but the fourth one has, which is butane. So when explaining the structure formula, I mean the isomers, will be using mostly the structure formula. So we want to look at this isomer of butane. First, you need to know the molecular formula of butane. If you're not sure, again, quickly use the general molecular formula to know. Okay, for example, we can say CnH2n plus 2, where there's n you put 4, but means 4. So C4, then H, again there will be 4, so 4 times that, 8 plus that becomes a 10. So butane is that one, okay? So the molecular formula is CN4H10. Now, how are we going to draw the isomers? How are we going to draw the isomers? Okay, so I'll draw the first structure, the one we usually know. Okay, make sure that all carbon atoms, that's 4 bonds, it's very important. So this is the structure which we usually know as butane. See? But we can also have a structure which looks like this. So 1, 2, 3. Then we have another carbon atom branching at the middle. See that there? We also have 4 carbons in it. Okay, so we have hydrogen there, hydrogen, hydrogen. Okay, so we have 4 carbon, 1, 2, 3, 4, and we have 10 hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Even here we have 4 carbons, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen. So these two, they have the same molecular formula. When writing their molecular formula, they will all appear like this. It's the same. But if you check, their structures are different. So these are what are called isomers. They have the same molecular formula, but different structure formula. This carbon atom is not always down there. If you want, you can put it on top. Okay, it's not always here. Now you must learn how to give names of these isomers. This one is very easy. It's just butane. The way it is, it's just butane. Now for isomers, there is a little problem there. This is butane. Now, what will be the name of this isomer? So we'll be killing 2 birds at once. We'll do the structural formula as well as naming. Now, when naming isomers of alkane or any other, isomers of any other homologous series, we follow these steps. 1, you identify the longest continuous straight chain of carbons. You need to identify which part has the longest or the highest number of carbon, which chain and straight. Which chain is straight and contains the highest number of carbon. So identify the longest chain. Then after you identify the longest chain, now you need to identify the group and the location of the group. A group, in this case, if we say this is our longest chain, 1, 2, 3, you even number them. Okay, but when numbering, you have to make sure that this group has the smallest number as possible. Now in this case, even if you count from that side, it will be at carbon 2. You count from this side, it will be at carbon 2. So first identify the longest continuous straight chain. If you check here, we have 2 chains. The one with 3 carbons, 1, 2, 3, and the one with 2 carbons, 1, 2. So the longest chain is this one. And the longest chain is the one who's going to have the parent, what is called the parent name, the major name. Okay, the longest chain will have the parent name. So in this case, we are saying that the one with 3 carbons is the longest chain, and it will form the parent name. So what is the name of the longest chain? So it has 3 carbons. If you check 1, 2, 3, what is the name of the longest chain? That is propane. Remember, propane is an alkane with 3 carbons. So this one has 3 carbons. Therefore, this longest chain is called propane. That is propane. Okay. Then we identify the group. The group is any atom which has been attached, or any compound which has been attached to the longest continuous chain. Now here, as I identified this one to be the longest chain, meaning we have this group here which has 1 carbon atom. Okay, so the group which we have there has 1 carbon. Now because it is a group, it will not be called methane. Whenever an alkane becomes a group or attaches itself to the parent chain there, it's no longer an alkane. It no longer be called an alkane. Instead to be called an alcohol. You see that, right? Alcohol. So in this case, instead of this called methane, it will be called methyl. Called methyl. Meth means 1. Now because it is a group which has lost 1 atom of hydrogen and attaches itself to the parent name, to be called a methyl, not methane. So the group is methyl. The group is methyl. Now, you always have to include its position. At which carbon is the group attaches itself to the parent chain? So 1, 2 is at carbon 2. So this group is at carbon 2. See that, eh? So the name of this isomer becomes 2-methyl propane. You write the parent name at the end, 2-methyl propane. So the name of this isomer is 2-methyl propane. Okay. Right. Now let us look at another isomers. The last one probably, and we go to the other part. Okay, so we look at the one with 5 carbons, which is pentane. Pentane, the same molecular formula again, so C5H4. Use the general molecular formula for you to know how this one is. Okay. Now this is pentane. We want to know its structure formula. This one, it has a lot of isomers. For example, the first one will be C. That's 5 carbon. forget, each carbon atom must have 4 bonds. So it's very important to take note of that. Okay, this is the pentane we know. See? Now when drawing the isomers, you can also make them according to how you feel like. For example, we can draw an isomer with the longest chain with the 4 carbon. It will be C, 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 C. Then you decide that the group will be attached there, the one which makes it the 5th carbon. Okay? Okay. Like that. Then we also have another isomer. I'll draw it here. 1, 2, 3. Okay. You make the longest continuous chain to be 3. Then you have another group this side, another group this side. They both contains, they all contains 5 carbon. They all contain 5 carbon. They all contain 5 carbon and 12 hydrogen. Okay, they all contain 5 carbon and 12 hydrogen, but their names will be different. They have the same molecular formula, different structure formula. This one is butane, just the way it is. I mean pentane. So this is pentane, the way we know it. Now, these two will be a bit different in naming, like what I'm doing from the previous example. You identify the longest continuous chain. So what we have here, for example, we have one. You identify we have 2 chains. 1, 2, 3, 4. This one has 4 chains. 1, 2. This one has 2 chains. So therefore, this becomes the longest continuous straight chain of carbon. So now, when numbering this, you have to make sure that this group is given the smallest number as possible. If you are to count from this side, 1, 2, 3, 4. This will be at carbon 3. But if you count from this side, 1, 2, 3, 4, this will be at carbon 2. So you have to count from this side. Okay? You count from that side because the group must be given the smallest number as possible. Okay? So what will be the name? Identify the longest continuous straight chain and give each name. So here we have 1, 2, 3, 4. What name is given to an alkane with 4 carbon? Of course, you're right. You may be right. Is butane. Okay, butane. Now, the longest continuous straight chain, as I said in the other example, becomes the parent name. So this is butane. Then you identify the group and the location of the group. So the group, again, it has 1 carbon, which will be called a methyl. Remember, this becomes a methyl, and is also at carbon 2. So the group is at carbon 2, and it is a methyl. You see that, eh? It's a methyl. So the name becomes 2-methyl butane. The name of this becomes 2-methyl butane. So we have 2-methyl butane. That's the name of that of this isomer. Okay, we go to that one. What is the name of that isomer? Very, very, very easy. As long as you're following these steps, becomes easy. So even there, identify the longest continuous straight chain. So 1, 2, 3, 1, 2, 3. So they both have 3. So just pick one. Okay. So if you pick this one, 1, 2, 3 as your mother chain, then these two becomes the groups. If you choose this one as your parent chain, then these two becomes the groups. Okay, so this will becomes 1, 2, 3. What do you call an alkane with 3 carbons? It's propane. Okay, now the groups attached to this is a methyl, this is a methyl, and they are both at carbon 2. They are both at carbon 2. So this becomes 2, 2. I've written 2, 2 because we have 2 methyl attached to the same carbon. So there are 2 groups attached to carbon 2. So 2, 2, then I'm going to use the word dimethyl. So this di simply means 2 methyl. Di means 2. So 2, 2 dimethyl propane. 2, 2 dimethyl propane. That's the name of that one. Okay, we can make little changes on this. We can make little changes on this. It can also be this way. It can also be this way. Okay, we have this one here. Okay. Can be like that. It can be like that. Now, if you choose this one to be your parent chain, then this is going to be carbon 1, carbon 2, carbon 3 to make this one the smallest number as possible. You see that, eh? But if you want to pick this one as your mother chain, 1, 2, and 3, this one becomes a group. You see, that becomes one group. Now the mother chain, of course, is still propane because there's 3 carbon. But the group now, it has 2 carbons. The group has 2 carbon. An alkane with 2 carbon is called the ethane. Now, since it is a group, it is no longer ethane, it will be called the ether. Okay? So the group is the ether. Yeah, then this group is attached at carbon 2. So that becomes a 2 ethyl propane. The naming is very, very easy if you have checked so far. Okay, so that's how we do with the isomers of alkene. If you have questions, leave questions in the comment section below. I'll be happy to respond to your questions. Now, the last part of today's lesson is looking at the reactions of alkanes. Reactions of alkanes. Okay. Reactions of alkanes. The reactions of alkanes. Now, alkanes undergoes 2 types of chemical reaction. Alkanes undergoes 2 types of chemical reaction. So one is what is called the substitution reaction. Substitution reaction. So substitution reaction, this is a reaction which takes place when in an organic compound there is a certain atom or groups of atoms which has been replaced by another atom or by another group in that compound. So substitution is the process of replacing an atom or groups of atoms from a compound by the other atom from another compound. Okay. So substitution reaction, for example, when you are to react an alkane with halogen, alkane plus halogen, alkane plus halogen is going to produce, we have alkane, going to have alkane plus plus hydrogen chloride. For example, hydrogen halide. Okay. Hydrogen halide. When you react an alkane plus hydrogen, you are going to form alkane as well as the hydrogen halide. So, example, we have okay, which alkane? We start with the methane itself, but we react methane plus any halogen, for example, chlorine, it's the simplest halogen you can use. Okay, it's going to produce chloromethane, plus hydrogen chloride. Okay. Hydrogen chloride. Okay, so that will be the product. The structure formula will be methane plus chlorine is going to produce. So what will happen here is one atom of chlorine will replace one atom of hydrogen from this methane. You see, so it's going to substitute this. When these two combine, when this has replaced this one goes there, and this one will swap and go and form a compound with the remaining lonely chlorine. So this forms there. We're going to have the chlorine, the one which has replaced hydrogen, and here we still have the same thing there. Okay, plus the hydrogen chloride there. So this is how substitution reaction takes place, where an atom replaces hydrogen atom from an alkane to form what is called the alkane. So this is called the substitution reaction. Now we can do this even for the other compounds. For example, we can use the propane. We can use propane. We can use propane. Propane has 3 carbon. So 1, 2, 3. Okay. Propane has 3 carbon. So if you check that, propane has 3 carbon plus let's use bromine. It's going to produce here. So again, one atom, any atom can be replaced. If you want, you can replace that one, you can replace this one. So any atom can be replaced. I'm not saying on that one, no. So this bromine is going to replace hydrogen from each compound, and it's going to form 1, 2, 3. Okay. So it has replaced this. We're going to have bromine there, and we still have the same things at the end there. So that is called the bromopropane. So when giving the name, just get the first, the suffix of, the prefix of halogens. So this is called the bromopropane. Okay, plus hydrogen bromide. So that's substitution reaction. Now, the other type of reaction which alkanes undergo is combusting reaction. The other type of reaction which alkanes undergo is combusting reaction. So what is combusting reaction? Combusting reaction is the burning of fuels with oxygen to produce water and carbon dioxide gas if there is sufficient oxygen. Okay, so combusting reaction is the burning of fuels with the oxygen to produce the carbon dioxide and water. That's what is called the combustion. Now these, sometimes when there is short supply of air or oxygen, which causes the incomplete combustion. So therefore, we have two types of combustion. What is called the complete combustion and the incomplete combustion. We have complete combustion and incomplete combustion. So complete combustion, this is where when you burn a fuel, or when a fuel is burnt with oxygen, it's going to produce water and the carbon dioxide gas. Then incomplete is when we react a fuel or burn a fuel with oxygen, and then it's going to produce water and the carbon monoxide. This is as a result of short supply of oxygen or limited supply of oxygen, in other words. So here we have two types of combustion reaction. We have complete combustion and incomplete combustion. Incomplete combustion is the burning of fuel with air to produce water and carbon dioxide, while incomplete combustion is the burning of fuel with oxygen to produce water and carbon monoxide. So if we write this equation, we are looking at alkanes, so I'll use alkanes. So for example, methane, here, we use methane, CH4 plus air, which is oxygen, it's going to produce water plus carbon dioxide. That is complete combustion. You see? Then if incomplete combustion, the same, CH4 plus air. Now this air is not enough to burn fully. It's going to produce water, H2O, then plus CO, which is carbon monoxide. These reactions takes place at very high temperature. Therefore, the water produces in form of the gas. Okay. You can also balance this, very important. You can also balance this reaction. So when balancing, carbon here is 1, carbon is 1, okay. Then we look at oxygen here is 2, oxygen here is 3. So again, to balance that, you can put put 2 here to make 4 hydrogen, oxygen. Then there also to put 2 to make 4 oxygen. Hydrogen is 4 now, even here is 4, so it's balanced. Okay, consider that. You can also balance this. Here oxygen, carbon is 1, carbon is 1. Here oxygen is 2. There oxygen is also 2. Hydrogen here is 4, hydrogen there is 2, so we put 2 there. Okay, we put 2, we make a balanced hydrogen. Oxygen changes, times 3. Okay, so those oxygen changes, I'm going to put 2 there to make it 4. Then we put 2 there to balance 4, but carbon is affected. So we're going to change here. We're going to change the number here. So we're going to put 2. Hydrogen is affected, becomes 8. So to make 8, we're going to put 4 here. Oxygen becomes 6 this side. Then to make it 6, we put 3. Okay, so here we have 4. Okay, let me use a different color. We have the 2. We have the 3. We have the 4. We have the 2. Okay. So this is about alkanes. In the next video, we're going to look at alkenes. So we're going to look at obviously the same structure. Look at the the formulas. Look at the names of these, how to isomerism, chemical reactions. Okay. So thank you for watching, and please, if you're first time to watch my videos, subscribe, like, and share the video. Leave questions in the comment section below, or any other topic you'd like me to shoot a video on. Okay, thank you. Bye bye.